I wanted to use some COVID examples to talk about principles of sampling and experimental design. So this is not a poll I'm aware of, but I am sure that these types of polls have been taken based on articles I've read about what's going on with COVID. So it says a nationally known polling organization developed a survey to research the attitudes and behavior of U.S. residents about COVID protocols. They asked demographic questions, age, race, gender, income level, education level, and zip code, as well as questions about wearing masks, COVID vaccinations, social distancing, and political affiliations. And things I've read in the paper seem to indicate that there are certain areas of the country and certain education levels, income levels, genders, races, or whatever, that have different attitudes about the COVID protocols, whether or not it's safe to attend school, whether or not you should wear masks, whether or not you should get a vaccine. All of those things differ in somewhat predictable ways in certain demographic groups. And so they've, found this out by looking at, there's certain states where kids have not gone to school all year long in any school because they are more afraid of infection than we are here in Indiana. And it seems like people on the extremes of both ends are totally ignoring the scientific evidence and basing their decision on something other than the kind of commonly accepted scientific evidence about some of these things. So anyway, it's been interesting to read about that. So I want to use that so let's say that's the kind of sample. We're trying to take a survey to represent the United States and get some answers to some of these questions. So some of the sampling methods that we've talked about in the past, simple random sample. That means that you're using the whole population as one big pool. You're stirring it up and dipping out a handful, and you get that sample. There's lots of different ways. You should be able to explain how to do that. Remember we talked about there was the hat method. So the hat method in this case would be something like, I don't even know how you'd use a hat method for the entire population of the United States. There really probably isn't a way to do that. You could, but you could. In a really big hat, yes. And you take like a giant hand or a crane or something, and you pluck out like a sample of them. You gotta mix it up.
Yes.
Yeah. Unfortunately, that could damage some of the more vulnerable Americans. But I think probably the random digit dialing is probably the closest way to get a simple random sample of the population. It's probably more likely that there's some stratified sampling involved because if you take 1,000 people, maybe you would totally miss a certain area of the country or a certain other demographic that you're looking for. So in stratified sampling, you are dividing them into groups that are all alike in some respect that you think would influence the response variables. So maybe you're going to divide people by zip code. Maybe you're going to divide people by education level first. Maybe you're going to divide income level. So maybe, and I would say probably in a sample of this survey of this type, there's probably going to be a multi-layer sampling method. My guess is probably a combination of stratified sampling and cluster sampling. Cluster is when you randomly select a group of people that are in close proximity to each other because it's more convenient to get to all of them easily. It's more practical and more cost effective. So maybe, let's say we're wanting to go by income level and maybe by zip code. Maybe zip code or income. Zip code probably does have a lot. So maybe they're going to group some zip codes by which zip codes tend to have certain income levels or education levels, and we have a bunch of different zip codes, and those represent a cluster, and then you randomly select a cluster, and you try to contact all the people in that zip code. That's probably a little ridiculous, but you maybe randomly select a neighborhood. Maybe you have a lot of similar neighborhoods. You randomly select among a group of neighborhoods. All of these methods, though, must involve random selection of some sort. So stratified sampling is when we have different groups have different characteristics, and you want to do a simple random sample in each group. Cluster sampling is you have kind of a microcosm of a mixture of people in the population, and you randomly select a cluster and you do everybody in the cluster. So I would suggest going back and reading these definitions or they're probably in your little, they're also in your little, your cards somewhere. They're in there, the little definitions. And just making sure you know the difference between those. Also with a simple random sample, make sure for any of the sampling methods, make sure you can explain the how to sample. And remember, you have to do it in sufficient detail that someone could duplicate your process by reading what you wrote. So you want to avoid the use of the word it. You want to be specific and say, here is how I would select. So I'm going to number the people, or I'm going to use a random number generator to generate certain numbers, and I'm going to pick these many and put them in this group and so forth. That's what you want to do. Now, the convenient sample is just what it sounds like. This is not a good sampling method. This is just saying, I'm going to go up to people that are close by and ask them questions. And this is not necessarily representative of the population. It is not random. Therefore, we can't use this to infer anything about the population with a convenient sample. Sometimes it's the only thing we can get, and so it's got some value, but recognizing it might not represent everybody. So how does bias occur? So let's talk about the different types of bias. In a response bias, responses are influenced. So maybe the wording of the question, maybe the person asking the question, maybe the environment in which the question is asked if it's a sensitive question. People are more likely to respond in a comfortable and honest manner to someone who is like them. So if you perceive that the person that's asking the question is very different from you and they might judge what you say, then you might not be willing to answer honestly. Non-response bias just means they don't respond. People don't answer their phone. They're not home. Maybe you get a hold of them and they refuse to participate. Those are all types of non-response bias. You can't get them somehow. They are unavailable or fail to respond. Undercoverage just means certain groups didn't get asked to start with. Like they didn't get included in the sample. So this isn't the case that people in the sample won't or can't participate. And this is people are left out of the population sampled. So the famous example of this that I gave earlier in the year was a magazine poll for Franklin Delano Roosevelt that they used telephone polling at a time when the majority of people in the country didn't have telephones, and so the only people that got asked were the wealthier people, and so we didn't get a representative sample. And in the past, I guess, that was still sufficient to predict the election, but in this case it did not. It really backfired on it. Voluntary response is people choose whether or not to be in the sample or not to be in the sample. In other words, this is non-random. This is not random. These three can all be random. The first three can all be perfectly, random samples. It's just either the way the sample's done, the way the survey is administered causes the response to be influenced. These people aren't available, and these people weren't ever asked in the first place. So when you talk about bias, you need to talk about, does it cause the response variable to go up or to go down? So you're going to say, whatever this bias is, what's it going to do to the response variable? What happens to the response variable as a result of this bias, and why? So, and how are included and excluded people different? Okay. So you have to put these two together, tie those together. How are the included people and the excluded people different in this case of these three? Non-response, undercoverage, voluntary response, and how might that affect the response variable? So some of the things, like people who work during the day are less likely to have time to participate, and those people might be different. They might respond to the question differently than people who don't work during the day. Or this group left out the people that are maybe recent immigrants and don't speak English well were left out because of the way the survey was administered, and those people might respond to the question in this way and cause the response variable to be either changed one way or the other, a higher percentage or a lower percentage, something like that. How voluntary response people tend to be people with strong opinions. So people with strong opinions about this issue might respond differently and cause a certain change in the response variable. So make sure that you go back and look and how do we talk about that. There's some examples in the practice problems. So online, there are, I think, 4 AP problems that kind of give a good sampling of some of the questions that get asked about these topics. Why is it so important to use a random sampling method rather than something more convenient? So the sample represents the population. If we don't have a random sample, we don't have any kind of assurance that the sample actually represents the population. We did some things in class where we chose what we thought was a random sample, and we were usually wrong. We usually tended to accidentally over-represent certain things more than others. I think we did one where we had to pick words out of a paragraph, and people tended to pick the average word a little bit too large. And so we overestimated the mean by doing that. I'm going to skip question number 4 for right now because we'll be talking more about inference stuff tomorrow. I need to shift this so I can get to. Oops, that's not what I meant to do. I can't get to my little button that moves me to the next page. There we go. Okay. All right, so the COVID, I was looking for an example of something involving COVID that might be an experiment, and I Googled effective COVID treatments, and I actually lifted this paragraph out of a real article about a real COVID trial, so this is not made up. The NIH COVID-19 treatment guidelines recommend the use of dexamethasone in certain people hospitalized with severe COVID-19. The recommendation was based on results from the recovery trial. In the study, more than 6,000 patients hospitalized with COVID-19 randomly received either dexamethasone or standard treatment. Patients who required supplemental oxygen or ventilators and who received dexamethasone were less likely to die within 28 days than those who received standard care. Dexamethasone did not have a benefit to patients who did not need respiratory support. So this actually gives the results of their test. So first question that you will be asked a lot is, how do you know it's an experiment? And you'll see in here, they randomly received a treatment. Okay, so there's a random treatment. So randomly assigned a treatment. And you don't need to write, you can write down stuff or not as you decide on this. I'm going to go really fast. What's the advantage of doing an experiment rather than an observational study? What can we infer from an experiment that we can't from an observational study? Cause and effect. Cause and effect can be determined. Which means in an observational study, they would not be able to say whether or not the medicine was more effective than no medicine at all with an observational study, but you can with an experiment. It seems a little callous, but obviously the protocols were I'm sure followed where patients or family members that acting on behalf of those patients were told, we have an experimental drug, would you be willing to try it? And the thing is, though, and they would be informed that they would be randomly assigned to a group, that they might get the placebo or they might get the real drug, but would you be willing to participate in this trial? Once they see that there's an effective, that one seems to be more than effective than the other, then they would certainly give the other group the medicine, once they see an effectiveness happening. But at first, some people did die because they didn't really know when they started whether or not this method would be effective. And I know it always seems really horrible, but that's what happens when you're dealing with something new. You don't know what's going to work and what's not. So people who got COVID early on didn't have nearly as many effective treatment options, but people who got COVID later got to benefit from things like this. Identify the subjects. Subjects here. 6,000 patients hospitalized with COVID-19. So there's our subjects there. Pretty obvious in this case. The subjects are whoever's receiving the treatments. All right, the treatments, and we also, we don't need to, we know what those are. The treatments, dexamethasone and standard treatment. Those were the treatments. The factors and the levels. This would be like if you had multiple things going on, like you were giving them dexamethasone and maybe some other drug together, maybe 2 drugs or drug and other therapy or something like that. That would be, they would both be factors. So this is where you could have maybe four different treatments. One treatment where the person got both drugs. One treatment where they just got drug A, one where they got drug B, and one where they didn't get either drug. And then you could compare, do those drugs work better individually or separately, or together or not at all? Yeah.
So would you be allowed to say that about this one, since it was talking about how dexamethasone didn't have any difference in people who didn't need respiratory support?
It's possible, although in this case, they probably are not at that point going to randomly assign someone to get a ventilator or not. So probably what they're going to do in this case is that would be a blocking variable. We would say, here are the group on ventilators, here are the group not on ventilators. We randomly assign some to get standard treatment and some to get the medicine. And when they did that, they found out that dexamethasone made a difference for the people on ventilators, but not much of a difference for the other people. So that would be a blocking variable. And we'll put that down. Matter of fact, we can go down right there. How would you improve the design by blocking? Maybe, so we could have one block. It would be people on ventilators, other no ventilators, or use other symptoms. So maybe they might want to block on a symptom like this. These people are having respiratory problems. These people are having high fever or whatever it was, that different things. I think for the most part with COVID, the main issue was the respiratory issues, but there were also some other maybe less common severe symptoms. So you're blocking, maybe you might want to block by age. Maybe you think age might have a factor. Maybe you want to block by gender. But the blocking variable should be some variable that may affect the response variable. So you wouldn't block on their flavor of ice cream because their favorite flavor of ice cream, because that probably has no effect on whether that medicine works. I know that's kind of a weird, but you wouldn't block on like what state they lived in or something like that, or their political affiliation. So you're not going to block on something that has nothing whatsoever to do with the response variable. So the response variable in this case would be their response to the medicine. So what might they measure? What does it look like they measured in this experiment for the response variable? Okay, death, but let's be a little more specific. Okay, so this could be a proportion of people who died, that we could measure whether they died in 28 days or not. So died in 28 days or not. In that case, we would be dealing with a proportion. Either they did or they didn't die within 28 days. And so we'd say what proportion? we might have, that could have been the number of days they lived. In that case, we'd be looking at a mean. Like, what's the average number of days lived after taking this medicine? Yeah, I think it's probably more likely to have been the first one. This is probably what they did. But I'm just saying, depending on what they measure, you're either going to have a mean or a proportion in this case. It can, if we did a chi-square, you maybe had how many, counting like, I don't see a chi-square one on this one necessarily, but you could also maybe have measured other symptoms. You could have measured like, if there was some way to measure lung capacity or breathing capacity or number of days on ventilator. There's all kinds of things. Number of days they needed a ventilator. That could be something that they, that is a possibility. That would be a mean. That would probably make more sense than the number of days they lived, because that could go on for a long time. Like, I got well. I'm living for a really long time after I was on here. So there's different things they could have measured. How could this experiment be implemented as a completely randomized design? And that is described above. You know, we just randomly assign half of the 3,000 to one treatment and half to the other.
And like having a hat with like 6,000 things on it with one with yes and one with no, with two different kinds of random.
Yes.
So both of those are like completely random, right?
Yes. Yeah. Coin flip would work. Once again, be able to describe that. Be able to describe how you did that, and make sure it's clear. Like, I would, for each patient, I would flip a coin. If they get heads, they get the dexamethasone. If they get tails, they get the standard treatment, and can do that for each patient or something. Yeah.
I'm trying to figure out how to ask this. So if we decide that 3,000 people in the batch are going to get the dexamethasone, and 3,000 are just going to get the standard treatment, then can't you only randomly assign them so much until you run out of people who get the dexamethasone, and then all the rest are just...
Well, it depends. You don't necessarily have to have exactly 3,000 in each group. It's just that you can't cherry pick and say, this person looks really sick, we better put them on the medicine. This one looks like the last, we'll put them on the standard treatment. Otherwise, then you have created some bias. And even if you, and you even could do it systematically. You could just say every other person that comes in, one, like the first person gets this, the next person gets that, and just go back and forth. As long as the people are coming in random sort of order. And it's very likely that they probably did some method of a coin flip, like each time someone comes in and you flip. How would you implement a randomized block design? So you would have to do a simple random sample within each block. So it's basically like you divide them up first, then you randomly assign, no, not a simple random sample, sorry, a random assignment is what I meant to say, random assignment within each block. So each block would get both treatments. So if you divided them by ventilators and non-ventilators, you should have about half of the ventilator patients getting one treatment, half the other, and then half of the non-ventilators. So you're going to just compare, like too many experiments within an experiment. You're going to just compare the ventilator people to each other, and you compare the non-ventilator people to each other to see what improvement they made. The advantage of blocking, like stratifying, is reduced variability in your results. So that is always the idea. Is there's going to be, if everybody that's in a block has a ventilator use and I see improvement, it's going to be compared to the improvement of someone who's also on a ventilator. Whereas if I have someone who's not on a ventilator, let's say, for example, someone not on a ventilator who gets the new medicine and someone who is on a ventilator who does not get the new medicine, I may see a huge difference in improvement. Partially is due to their original condition. So dividing them by their symptoms or by their level of severity of the illness might be good to do first. So you reduce variability this way. Okay, could this experiment be double blind? Okay, so if they've got a dexamethasone person, are you giving them some sort of a placebo treatment that looks exactly the same? Yeah. Okay, that would make it blind, the treatment blind. Could the doctors evaluating the symptoms after the treatment be blind as to which type of patient they're evaluating? Yes, so we could make this double blind. Yes, so we could have a fake treatment, and which is of course the placebo, and we could have doctors evaluating, not knowing. You know, when I write really fast, I don't spell well. Doctors evaluating, not aware of the treatment. So yes, we could do that. What's a control group? Oh, sorry, do you have another question? Yeah, go ahead.
Okay, so maybe this is just do we need the doctors evaluating them to be blind to whatever treatment it is?
Sometimes yes, sometimes no. Because all diagnosis involves a judgment call to some extent. So if they're evaluating symptoms, like has COVID gotten better, maybe if they're just seeing how long they lasted, you know, if they're just seeing like, it depends what they're measuring. So it might not. We might not. Yeah. If that's all that they're measuring, then no, you would not need necessarily the second part to be blind. So
would you be allowed to call that double blind, or would you just say single blind? There's no need to double blind it.
Yeah, if there's no need to double blind, it would just be single blind. Yeah. What's a control group? If you were to define it, what's a control group? Say it again. Okay, when you say the baseline, what about that group? They are getting no treatment or placebo, which might involve placebo. So control group, yeah. So no treatment. So if the treatment is the dexamethasone, they are not getting the dexamethasone. So we have a group that's getting the dex. So obviously they're not going to, in any kind of medical trial, they're not going to withhold all treatment, but they're going to withhold the particular thing they're testing. They're going to get the regular treatment that everybody gets, and everybody gets that. So that's like the baseline, as Sydney said. So in this case, no dexa thing. They're not getting that. And they're used as a baseline of comparison. Yeah. So yes. So anyway, we'll kind of continue that. And I'm sorry, I know we're talking. I'm not giving you guys a lot of time to work on your own, but I feel like this is the most efficient way to quickly run through a lot of topics that we need to. So, as you have time, when you're not studying for other things this week, definitely go and look at the extra stuff I have online, extra practice problems and multiple choice or free response for these topics. It would be really helpful.